Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0101 indicates a problem with the mass airflow MAF sensor circuit, specifically indicating a range or performance issue. This diagnostic code is crucial for maintaining optimal engine performance as the MAF sensor measures the amount of air entering the engine, which the Engine Control Unit, ECU, uses to calculate the appropriate fuel injection and ignition timing. If the MAF sensor is not functioning correctly, it can lead to reduced engine performance, increased emissions, and potentially damage to other engine components. The MAF sensor is typically located in the air intake duct between the air cleaner and the throttle body. Proper diagnosis and repair are essential to restore normal vehicle operation and avoid further complications. Before beginning troubleshooting for DTC P0101, ensure that any related DTCs, such as P0106, P2228, or P2229, are addressed first, as they may contribute to this issue. The MAF sensor plays a vital role in the engine management system. It informs the ECU about the volume of air entering the engine, allowing precise adjustments to the air-fuel mixture for optimal combustion and performance. The sensor is typically located in the air intake duct, which connects the air cleaner to the throttle body, making it an integral part of the air intake system. Additionally, other components that need to function correctly include the positive crankcase ventilation, PCV hose, intake air duct, and the air cleaner. Any damage or malfunction in these parts could lead to inaccuracies in the MAF sensor's readings, causing the P0101 DTC to trigger. Understanding the importance and location of these components will aid in effectively diagnosing the issue at hand. Several issues may lead to the activation of DTC P0101. First, poor connections at the MAF sensor, intake air temperature, IAT sensor, or powertrain control module, PCM, can disrupt the signal flow and lead to incorrect readings. Secondly, damage to hoses, like the PCV hose or the brake booster hose, can allow air leaks, which can interfere with the accurate measurement of air entering the engine. Additionally, a dirty air cleaner can restrict airflow and produce erroneous data for the ECU, prompting the DTC to store. Recognizing these potential causes is vital for narrowing down the troubleshooting process and understanding where faults may lie within the air intake system. When DTC P0101 is present, several noticeable symptoms can manifest in the vehicle's operation. Drivers may experience poor engine performance, including hesitations during acceleration and overall sluggishness. An increase in fuel consumption can also be observed, as the engine struggles to maintain optimal air-fuel ratios due to inaccurate MAF readings. Additionally, the check engine light will likely illuminate on the dashboard, indicating that a problem has been detected within the engine management system. Such symptoms should not be ignored, as they can lead to further complications if left unaddressed. Therefore, prompt diagnosis and repair are essential for restoring the vehicle's performance and efficiency. The first step in troubleshooting DTC P0101 involves a thorough condition check of the various components related to the air intake system. Begin by inspecting connections to ensure they are not compromised due to corrosion or looseness. Additionally, look for visible damage to essential components, including the PCV hose, intake air duct, air cleaner, and the purge line. Any visible defects or wear can indicate a source of the problem, leading to incorrect MAF sensor readings. After conducting this preliminary inspection, determine if all parts are in satisfactory condition. If any damage is found, it's crucial to repair or replace those components before moving forward in the troubleshooting process. In the second troubleshooting step for DTC P0101, focus on the visual integrity of the intake air duct itself. Check for any signs of physical damage, such as cracks or breaks, that could impact airflow from the throttle body to the air cleaner. Additionally, ensure that the duct is securely connected and not loose at either end, as a loose duct can lead to unmeasured air entering the engine, skewing the MAF sensor output. If the duct appears to be damaged or improperly connected, it must be either reconnected securely or replaced with a new part. Moving to the next troubleshooting step is contingent upon confirming that the intake air duct is in satisfactory condition. The third step in diagnosing DTC P0101 involves checking the air cleaner element for cleanliness and functionality. A dirty or clogged air cleaner can severely restrict airflow, causing the MAF sensor to send inaccurate data to the ECU. Perform a visual inspection to assess the condition of the air cleaner. If dirt is visible or if the element appears congested, it is a strong indication that replacement is necessary, as airflow must remain unobstructed for the engine to operate efficiently. If the air cleaner is found to be in good condition, you may then proceed to the next troubleshooting step, focusing on checking the MAF sensor's signal output under specified conditions. Step 4 of troubleshooting DTC P0101 requires conducting a signal check on the MAF sensor while the engine is not running. Begin by turning the vehicle to the off mode, then transition it to the on mode without starting the engine. This will allow you to assess MAF sensor parameter values using the Honda Diagnostic System, HDS. Pay close attention to the signal value, which should read over 0.5 grams per second, G per second. If the MAF sensor's output matches this threshold under these conditions, you can proceed to the next troubleshooting step. However, if it does not meet the threshold, replacing the MAF sensor or the IAT sensor may be warranted. In this fifth troubleshooting step, the MAF sensor signal should be checked with the engine running to observe its real-time performance. Start the engine and vary the engine speed between 2,000 and 3,000 revolutions per minute, RPM. During this process, use the HDS to monitor the MAF sensor readings in the data list. A functioning MAF sensor should show a change in the readings as the engine speed varies, with values reflecting the increasing airflow. If the readings do not change, this could indicate a faulty MAF sensor or IAT sensor, necessitating their replacement. If readings increase appropriately, you can continue to the next step in the troubleshooting process. The final troubleshooting step involves a thorough check of the MAF sensor's performance under specific conditions. First, hold the engine speed steady at 3,000 RPM without load, ensuring the vehicle is in the appropriate transmission mode. This simulates operational conditions where the radiator fan activates, allowing for comprehensive evaluation. After allowing the engine to stabilize, test drive the vehicle, monitoring the OBD, onboard diagnostics, system for any new occurrences of DTC P0101. Pay particular attention to the freeze data parameters that were recorded previously, such as engine speed, vehicle speed, and measurements from the manifold absolute pressure, MAP, and throttle position, TP sensors. If DTC P0101 is indicated as failed on the HDS, replacing the MAF or IAT sensor is necessary. If it shows as passed, check connections for potential intermittent failures. After completing all necessary diagnostic checks and repairs for DTC P0101, it's essential to conduct a final repair verification. Start by confirming that the replaced or repaired MAF sensor is functioning correctly. This can be done by rechecking the corresponding signal values using the HDS to ensure they align with expected parameters. It's also crucial to assess whether any symptoms that arose before repairs, such as increased fuel consumption or poor engine performance, have been resolved. Finally, clear all DTCs from the system and perform a follow-up test drive, rechecking for any new occurrences of DTC P0101 or related codes through the HDS. This step ensures that the problem has been fully resolved before concluding the repair process. Preventive maintenance is crucial in ensuring that issues like DTC P0101 do not recur in the future. Regularly checking the air intake system for any signs of wear, including hoses and ducting, can significantly minimize the chances of airflow disruptions. Keeping the air cleaner element clean and replacing it as needed will help maintain optimal airflow, preventing the MAF sensor from receiving incorrect readings due to blockages. Additionally, routinely inspecting all connections related to the MAF and IAT sensors will help identify any potential issues before they become significant problems. Implementing these preventive measures will promote reliable vehicle operation and engine performance. In conclusion, DTC P0101 highlights the significance of a properly functioning MAF sensor within the engine management system. A thorough diagnostic process is essential in identifying the source of the problem, ensuring that no potential issues are overlooked, from poor connections to physical damage in vital components. Following the structured troubleshooting steps leads to effective repairs that restore optimal engine performance. Moreover, implementing preventive maintenance measures plays a key role in avoiding future occurrences of similar DTCs. By staying proactive with regular inspections and maintenance, drivers can maintain their Honda HR-V's efficiency and reliability over time. Please like and subscribe to the channel. See you next time.